All right, so today we're just talking about proportions in triangles, and so there's a couple vocab theorems that we're going to start with. So the side splitter theorem is first, and that says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So see, these two are parallel, which means that 10 over 5 would be the same as 16 over x, and you could use that then to solve for that missing piece, and that's because those two lines here are parallel. Okay, so then the other two parts of the triangle are proportional. And the corollary to that is like if three, so that's just like an add-on to it. So if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So that means that B over A would be the same as D over C, because B and D are going to have the same rate of, or the same similarity ratio, and A and C will as well. So then the last vocab here is if a ray bisects an angle of a triangle, then it divides the opposite two segments that are proportional to the other side of, and they are proportional to the other two sides. So like that means that this x and y, x over y would be the same as q over p, if those are q and p. So like x and q and y and p would have that proportionality. Okay, so I'll show you some examples of how to use those, but definitely make sure you have those written down and are aware of how to use those. Okay, so this is going to use a side splitter theorem. So that says that these two, so 6 over 10, is going to be the same as y over 12. Okay, and so we can then cross multiply here. So 10 times y and 6 times 12. So we get 10y equals 72. And then if we divide both sides by 10, we get y equals 7.2. Okay, and again, it's because of that proportionality. Okay, this one here is going to use the corollary, so just that one, that if the lines are parallel, we can then use that to solve for missing pieces. And so I see that these are the two that are filled in, the 6 and the 5, so we're going to use that as our first ratio, so 6 over 5, and then we can take the side that's on the same transversal as the 6 and say x over 12.5, and then solve that. I can also say 6 over 5 is equal to, and then I can use the 9 and the y here, and so the 9 needs to be in the same spot as the 6, so on the top, and the y needs to be on the bottom. And now I can solve both of these to find the missing pieces, and that's because all of those lines are parallel. So if I cross multiply, I get 5x equals 75. If I divide by 5 on both sides, I get the x is equal to 15. So I've solved for that first piece. Now I can cross multiply here and get 6y equals 45, because 5 times 9 is 45. And if I divide by 6 on both sides, I get y equals 7.5. And again, we're using the proportionality, or the corollary to the side splitter theorem, because they're all parallel, then these transversals have proportional relationships as well. Okay, this last one is the triangle angle bisector theorem. So it's saying that the two sides are proportional if this is an angle bisector. So like 30 over 40 would be the same as x over 24, or x over 30 would be the same, or would be equal to 24 over 40. Either way you want to set that up. So I'm going to say x over 24 equals 30 over 40. Okay, so I cross multiply and I get 40x equals 720. If I divide both sides by 40, then I get x is equal to 18. And that is it for proportions in triangles.